Carbohydrates are classified on the basis of their behavior to hydrolysis into three categories. The first type are the monosaccharides. These are simple carbohydrates which cannot be hydrolyzed into any other simpler carbohydrates. Examples are glucose and fructose. Oligosaccharides are those which on hydrolysis will break down to give 2 to 9 smaller monosaccharide units. They may be disaccharides, trisaccharides or tetrasaccharides. Examples of disaccharides are sucrose and maltose. The third category are the polysaccharides, which on hydrolysis will give a large number of monomeric units. Examples of these are starch, cellulose and glycogen. Carbohydrates which are sweet are called sugars and those which are not sweet are called non-sugars. Monosaccharides and disaccharides form sugars while the polysaccharides are non-sugars. The chief aldohexoses are D-glucose, D-galactose and D-mannose. Fructose is a ketohexose. This is the structure of glucose. The straight chain structure has 6 carbon atoms in a straight chain and 5 hydroxyl groups. There is one aldehyde group and that is the reason why it is called an aldohexose. Hex stands for the 6 carbon atoms in a straight chain. Aldohexose means a combination of hydroxyl as well as the aldehyde group present in the molecule. Note here that on the third carbon atom, the arrangement of the hydroxyl and the hydrogens are as shown here. This is the structure of fructose, which has got a ketonic group and 5 hydroxyl groups. That is why it is called a ketohexose. Again here, the third carbon atom has the hydroxyl on the left and the hydrogen on the right, which is different from the arrangement in the other carbons. In long chain hydroxyaldehydes, there is a possibility of an intramolecular hemiacetyl formation resulting in the formation of a cyclic structure. Here, the carbonyl O being more electronegative tends to pull this electron cloud towards itself, as a result of which it gets a negative charge and the proton from here migrates and adds on to give a COH bond there. This results in a new linkage between the carbon, the first carbon and the fifth carbon via an O. This type of linkage results in a cyclic formation. A 6-member cycle is formed. 1, 2, 3, 4, 5, 6. That has been represented in the cyclic structure here. This is the first carbon. The third carbon note has got OH, the fourth is HOH, and the fifth carbon is attached to the CH2OH group. The first carbon may differ in the orientation of the hydroxyl groups, resulting in the formation of 2 anomers called the alpha D-glucose form and the beta D-glucose form. Here are some examples of disaccharides. Sucrose is made up of 1 unit of glucose and 1 unit of beta D fructose. Therefore, on hydrolysis, it will break down to give you these 2 monosaccharides. Lactose, again a disaccharide, is made up of galactose and glucose. Maltose is made up of 2 units of alpha D glucose. It is seen here that 2 monomeric units are condensing together with the elimination of water to form a disaccharide. The 2 monosaccharides are held together by a linkage which is called the glycosidic linkage.